Let us discuss the effect of changing concentration on the cell potential and electrode potential. So, effect of changing concentration on the cell potential and the electrode potential. Now, let us consider this reaction. A moles of A plus B moles of B gives M moles of M plus N moles of N. Now, for this reaction, we can write the concentration quotient Q as this: products in the numerator and reactants in the denominator. So, this is the expression for the concentration quotient, and Q we can write at any instant of time. Then we also know from the thermodynamics that the free energy change and the standard free energy change, they are related by this equation. And we have also derived the relation between the free energy change and the potential as this: delta G is equal to minus of NFE, where E is the cell potential, and delta G degree, standard free energy change, is equal to minus NF E degree, where E degree is the standard cell potential. Now, if you put the value of the delta G and the delta G degree in this equation, it gives minus of NFE is equal to minus of NFE degree plus 2.303 RT log of Q. Now, divide on both sides by minus of NF. So, it gives this equation, that E is equal to E degree minus 2.303 RT upon NF log of Q. Now, this equation is known as the Nernst equation. Now, at 25 degrees Celsius, we know that the value of 2.303 RT upon F is equal to 0.059 volt. So, we can simplify our Nernst equation as this: E is equal to E degree minus 0.059 upon N log of Q. So, this is Nernst equation at 25 degrees Celsius or 298 Kelvin. Now, in this equation, Q stands for the concentration quotient, and if Q is less than 1, it means the reactant's concentration is less than the product's concentration. It means log Q is less than 0 and E will be greater than E degree cell. So, this is our case number 1. Second case is if Q is greater than 1, it means the reactant's concentration is greater than product's concentration. It means log Q is greater than 0 and E will be less than E degree cell. And the third case is if Q is equal to 1, it means the reactant's concentration is equal to product's concentration. It means log Q is equal to 0 and E will be equals to E degree cell. And at equilibrium, no current is flowing through the cell, and as a result E cell is equal to 0 at equilibrium, and Q then becomes the K, where K stands for the equilibrium constant. And this Nernst equation is applicable to a half cell as well as to the complete galvanic cell. Now, first we will apply the Nernst equation to a half cell. Now, suppose you are given this: E degree of silver plus to silver, the standard electropotential of silver electrode is 0.80 volt. And the question is calculate the electrode potential of silver electrode at silver ion concentration equals to 10 raised to power minus 3 moles per liter. Now when we say electrode potential, it always means the reduction potential. Our aim is to find out the electrode potential for this electrode. Ag plus 1 electron to give silver solid, and for this reaction the n equals to 1, only 1 electron is involved in this reduction reaction, and the Q is equal to 1 upon silver plus ion concentration. Silver solid concentration is 1, it does not change with time, so it does not appear in the Q expression. Now silver ion concentration is 10 raised to power minus 3, and Q is equal to now 10 raised to power 3, and log Q is equal to log of 10 raised to power 3, and this is 3. Now we write the Nernst equation for this half reaction. Electropotential of the silver electrode is equal to the standard electropotential of silver minus 0.059 upon n log of Q. Now we know each and everything in this equation. We know standard electropotential of silver electrode is 0.80 minus 0.059. We know the value of n, that is 1 in this case. We also know value of the log K, which is 3 in this case. Electrode potential of the silver electrode is equal to plus 0.80 minus 0.177 is a plus 0.623 volt. So this is the electrode potential of the silver electrode when the silver ion concentration is reduced to 10 raised to the power minus 3. Now we take one more question. The question is calculate the electrode potential of the hydrogen electrode at pH equals to 10 at 25 degree Celsius. As we know, the E degree value of the hydrogen electrode is 0 volt. Our aim is to find out the electropotential of this electrode, 2H plus ion plus 2 electrons to give H2 gas. Now we write the Nernst equation for this. E H plus oblique H2 is equal to E degree H oblique H2 minus 0.059 upon n in this case is 2, log of 1 upon H plus ion concentration raised to the power 2, and the pressure of hydrogen gas is taken as 1 bar. So as a result, the hydrogen gas does not appear in this Nernst equation. So electropotential of hydrogen electrode is equal to 0 minus 0.059 upon 2, and we write log of H plus ion raised to the power minus 2. And electrode potential of hydrogen electrode is equal to minus 0.059 upon 2 into 2, and we write this way minus log of H plus ion concentration. And minus log of H plus ion concentration is called the pH. So electrode potential of the hydrogen electrode is equal to minus 0.059 into pH. Now in this question the pH is equal to 10, so we put the value of the pH 0.059 into 10. So the electrode potential of the hydrogen electrode at pH equals to 10 is minus 0.59 volt. So this is our answer. So this is very important relation, that electrode potential of the hydrogen electrode and the pH, they are related by this equation. So whatever the pH is given, just put the value of the pH and calculate the electrode potential of the hydrogen electrode. Now next, this Nernst equation is also applicable to the complete galvanic cell. Now we will solve two questions for the complete galvanic cell. Now this is our first question. This is a cell given, this is called Daniel's cell, zinc solid, zinc 2 plus iron aqueous, and the concentration is 0.001 mole per liter. And cathode is copper Cu2 plus of concentration 0.1 mole per liter and copper solid. Their electropotentials are given, E degree of zinc 2 plus to zinc minus 0.76 volt, E degree value of the copper 2 plus to copper is plus 0.34 volts. And our question is calculate E cell at 25 degrees Celsius, calculate the cell potential, calculate the cell EMF. Now in this case, first we write the Nernst equation, and our Nernst equation is this: E is equal to E degree minus 0.059 upon N log of Q. So to find the cell potential, we should know the value of the E degree, N, how many moles of electrons have been transferred from anode to cathode, and also the value of the Q. Now as the cell is already given, we can calculate the E degree cell as this: E degree cathode minus E degree anode. Now cathode is copper and the potential of copper electrode is 0.34, minus anode is zinc 0.76 volt. So the standard cell potential is equal to plus 1.10 volt. Now to find the value of the N, we should write the two half reactions. And this is our anodic half reaction, that zinc solid gets oxidized to form Zn2 plus aqueous plus 2 electrons. This is our anodic reaction. And the cathodic reaction is copper 2 plus, it's a reduction of copper 2 plus 2 electrons to give copper solid. Now if you look at these two half reactions, 2 moles of electrons have been transferred from anode to cathode. So N is equal to 2. Now we write the net cell reaction, and our net cell reaction is this: zinc solid plus the copper 2 plus iron aqueous gives Zn2 plus aqueous and the copper solid. Now we write the expression for Q. Now Q expression is zinc 2 plus iron aqueous in the numerator and the copper 2 plus iron concentration in the denominator. Zinc solid and copper solid, they do not appear in this Q expression. And next we know the value of the zinc ion concentration. It is at 0.001 upon copper ion concentration is 0.1. It comes out with 10 raised to power minus 2. So once we know the value of the Q, 10 raised to power minus 2, we can find log Q. Now log Q is equal to log of 10 raised to power minus 2, and this is minus 2. Now we apply the Nernst equation, that E cell is equal to E degree cell minus 0.059 upon N log of Q. Now put the value of E degree cell plus 1.10 minus 0.059 upon, put the value of N, that is 2, and log Q is minus 2. So E cell in this case is equal to plus 1.10 plus 0.059, and E cell is equal to plus 1.159 volt. And since the E cell is positive, it means the cell is spontaneous. Cell can do work on the surrounding. And the delta G for this reaction, which is taking place in this galvanic cell, will also be negative, and the reaction is called spontaneous reaction. Now we take one more question. Now suppose you are given this cell, copper solid, copper 2 plus an aqueous, it's a 0.001 mole per liter, and cathode is also made up of copper, and this is 0.002 moles per liter, and copper solid. And the question is again, calculate E cell at 25 degrees Celsius. Now in this case, our electrodes are made up of copper, anode as well as cathode. Therefore, E degree cell in this case will be 0. Next we write the two half reactions, and our anodic half reaction is this: copper solid gets oxidized to form copper 2 plus iron, concentration 0.001 mole per liter, plus 2 electrons. This is our anodic half reaction. And the cathodic half reaction is this: copper 2 plus ion concentration 0.002 moles per liter is reduced to form copper solid. And the net reaction is copper 2 plus ion aqueous of concentration 0.002 moles per liter is changing to copper 2 plus ion aqueous of concentration 0.001 mole per liter. And if you look at the two half reactions, 2 moles of electrons have been transferred, so N is equal to 2. And then we write the expression for Q. Q expression is products in the numerator and the reactants in the denominator. And the Q comes out to be 1 by 2, and log Q is equal to log of 1 by 2 is equal to log 1 minus log 2, and log 1 is 0 and log 2 value is 0.30. So log Q in this case is equal to minus of 0.30. Now we write the Nernst equation and then we put the values. Now E cell is equal to E degree cell minus 0.059 upon N log of Q. Now E cell is equal to E degree cell in this case is 0 because both the electrodes are of the same metal, copper, minus 0.059 upon N is 2 in this case, and log Q is minus 0.30 in this case. So this comes to be plus 0.59 into 0.15, and this is equal to 0.00885 volt. So this is E cell. Now in this case both the electrodes are same, anode as well as cathode, but still there is some output potential. It's a positive potential. It means the cell is spontaneous, right? Cell is doing work on the surrounding. It's because of the difference in the concentration of the two half cell solutions. Now these type of galvanic cells having same electrodes concentration of the two half cell solutions are called concentration cells. Concentration cells. So we can apply the Nernst equation to calculate the cell potential for a galvanic cell, also for a concentration cells. And we can also use the Nernst equation to calculate the electrode potential under non-standard conditions. But we can also use the Nernst equation to find the Q expression. And from Q we can calculate the concentration of any unknown substance. So that is the utility of the Nernst equation. So that's all about Nernst equation in this video.